Yes, students. First, let us take some few questions on wave optics. Then we'll take the ray optic questions. See here, the corpuscular theory of light was explained. Is what? It is a Newton corpuscular theory. So this, according to this Newton's corpuscular theory, it explains what type of nature? Particle nature. So definitely option 1A is the answer, right? According to corpuscular theory of light, the different colors are due to the different sizes of the corpuscles. All corpuscles are not of the same size. Because of the different sizes of the corpuscles, the different colors are going to be there according to Newton corpuscular theory. According to Huygens wave theory, we can find the geometrical method to find what? A wavefront. It is used to find, it is the method used to find what? Wavefront. This fourth and fifth is not required. The ratio of the intensity
now it is removed from the syllabus, no, sir?
Yeah, it is not there in the syllabus, sir.
Right, sir. Right, sir. Thank you, sir.
The ratio of the two intensities are in the ratio 1:25. What is the ratio of their amplitudes? Students, we know that the intensity is directly proportional to the square of the amplitude. So amplitude is directly proportional to the square root of the intensity. So what is the ratio of the amplitude? A1 by A2. It is root of I1 by I2. So root of 1 by 25 is what? 1 by 5. So what is the ratio of the amplitudes? 1:5. So option D is the right answer. Even the seventh one is not there because maximum topic is deleted in wave optics, students. For constructive interference to take place of wavelength lambda, what is the path difference? What is the condition for the path difference of a constructive interference? It is n lambda. So path difference for constructive interference should be equal to n lambda. So option C will be the answer. For constructive interference, path difference must be equal to n lambda. What about the ratio of the intensities of two waves? I1 is to I2 is 4:1. What is the ratio of their amplitudes? Intensity is directly proportional to square of the amplitude. So what is the ratio of the amplitude A1 by A2? It is root of I1 by I2. So what is the root of I1 by I2? Root of 4 by 1. What is root of 4 by 1? 2:1. So what is the ratio of the amplitudes? 2:1. Even 10th is not there. In our syllabus, we are going to deal with the equal amplitude, students. Unequal amplitudes are not there in the syllabus now. So what is the Huygens principle of secondary wavelets may be used? It is used to explain the new position of the wavefront. It is used to find the new position of the wavefront. Distance between the source and the screen is doubled. What is the intensity on the screen will be? Intensity is inversely proportional to the square of the distance. Intensity is inversely proportional to the square of the distance. If the distance is doubled, intensity will become 1/4 of the intensity. So option D will be the answer. In the interference pattern, you know that in the interference, the two light waves are going to be conserved, but the energy is going to be redistributed. Option C is the right answer. Look at this. In Young's double slit experiment, slit width or in the ratio. Slit width means D1 is to D2. Slit width or in the ratio 1 is to 9. Then, what is the ratio of the intensity of the minima to that of maxima? What is the intensity of the minima to maxima? Now, please remember, amplitudes and the slit width are in the directly proportional. Amplitude is directly proportional to the slit width. So if the slit width are in the ratio 1 is to 9, amplitude must be in the ratio 1 is to 9. So what must be the intensity ratio? I mean, this slit width is directly proportional to intensity ratio. More the slit width, more the intensity of radiation is going to come out. So if the slit width are in the ratio 1 is to 9, intensity will be in the same ratio, student, 1 is to 9, not the amplitude. Slit width is directly proportional to the intensity. If the width of the slit increases, more intensity of light is going to emerge out. So intensity is directly proportional to the slit width. In certain double slit experiment, fringe width is found to be 1 millimeter each for the wavelength of 5000 angstrom. Keeping the setup unaltered, another wavelength is used, that is 6000 angstrom. What will be the fringe width will be? What is the formula for the fringe width, student? Fringe width is nothing but lambda capital D by small d. So how the fringe width and lambda are related? Fringe width is directly proportional to the wavelength. So what is beta 1 by beta 2 then? It is equal to lambda 1 by lambda 2. Beta 1 by beta 2 is equal to what? Lambda 1 divided by lambda 2. So what is the first fringe width? It is 1 millimeter divided by beta 2. The first wavelength is 5000 angstrom. Second wavelength is 6000 angstrom. So cross multiplication, beta 2 will be equal to 6 by 5. So 6 by 5 means it is 1.2 millimeter. So option C will be the answer. Look at the 17th one. The figure shows the distance traveled by Px is n lambda. P2x is n lambda. Then Q2x is n plus 2 into lambda. So between this Px and Qx, what is the path difference? Path difference is n plus 2 lambda minus n lambda. So n lambda plus 2 lambda minus n lambda. So plus n lambda minus n lambda will get cancelled out. So delta x will be equal to 2 lambda. So path difference must be equal to 2 lambda. So if it is 2 lambda means it is must be a bright band, isn't it? Which is the bright band here? Second bright band. Because the path difference we got in the form of 2 lambda. So it forms a second bright band. It forms a second bright band. In Young's double slit experiment, glass plate is placed before the slit which absorbs off the intensity of light under this case. See here the glass plate is before place the slit. So if I say this is the slit, before this slit, the glass plate is placed. So if I incident the intensity of light, this is going to absorb some intensity means definitely on the slit, we are incidenting with the less intensity only. Let us I0 by 2 or I0 by 3, but less intensity. But interference will take place here. But the interference intensity will be less. So there will be a bright fringes and the dark fringes, but with the less intensities. In Young's experiment, distance between the slit is reduced to off. Distance between the slits is reduced to off, students, of the distance between the slit and the screen is doubled. That is capital D dash will be 2D. So what happens to the fringe width? What's the formula for the fringe width I have given? It is lambda capital D by small d. What will be the new fringe width? Capital D is doubled. Small d is offed. So small d is 1 by 2d. Capital D is 2d. So new fringe width becomes 4 times of beta. So it will become 4 times. So the fringe width will become 4 times. Yeah, this is very important, students. So many times they have asked. Fringe width is found to be 0.4 millimeter. Whole apparatus of 4 by 3 is immersed. What will be the new fringe width? New fringe width. So please remember, new fringe width is equal to fringe width divided by n. What is n represents? Refractive index. So beta dash is equal to beta divided by n. So new fringe width will be initial fringe width, that is 0.4, divided by the refractive index, that is 4 by 3. So this 4 and 4 will get cancelled. 0.1 into 3 will be 0.3. So the new fringe width will be 0.3 millimeter. 0.3 millimeter. Next one. In Young's double slit experiment, phase difference between the light waves reaching the third bright fringe will be what? So they are talking about the third bright fringe. For the third bright fringe, what is the phase difference condition? It is 2n pi. What is path difference condition? N lambda. For third bright means it will be 6 pi and it will be 3 lambda. So phase difference must be equal to 6 pi. Path difference will be equal to 3 lambda. Look at the options. What they have given? They have given as D. Option D, 6 pi. In two separate setups of Young's double slit experiment, fringes of equal width are observed. What is the wavelength ratio lambda 1 by lambda 2? It is 1 by 2. Slit separation D1 by D2 is 2 by 1. So what is the ratio of the distance between the slit and the screen? That is D1 by D2. They are telling that the fringe width is of equal width. So beta 1 equals to beta 2. So you know the formula for the fringe width. Beta equals to lambda capital D by small d. So beta is directly proportional to lambda. So it will be lambda 1 by d1 equals lambda 2 by d2. For the capital D, let it be d1 and d2. So what is d1 by d2 from this equation? Lambda 2 by lambda 1 into d1 by d2 on cross multiplication. What is lambda 2 by lambda 1? That is 2 by 1. What is d1 by d2? It is 2 by 1. So capital D by d1 by d2 will be 4 is to 1. So option A will be the answer. No need to analyze this, students. Angular bit. This also not required. This is quite simple. You can do it for an assignment. Later, I will share this PDF. Look at the 26th. Slit separation is 0.5 millimeter. Interference pattern is obtained on the screen means capital D. Wavelength of light used is 6000 angstrom. They're asking what is the separation of the third bright fringe. They're asking the distance of the third bright fringe. What's the formula for the third bright fringe? It is 3 times of lambda capital D by small d. 3 times of lambda capital D by small d. So 3 into, what about lambda? 6,000 angstrom by capital D is anyway 1. What about small d? It is 0.5 millimeter. 0.5 into 10 power minus 3, which is equal to 0.5 is 1 by 2. So 1 by 2 goes up 12,000. 12 threes will be 36. So approximately you can take the option 3 and 6 means 3.5 millimeter. Because 0.5 is 1 by 2, so 2 goes up. So 2 3 is 6. 6 into 6 will be 36,000. So minus 3, when it comes to numerator, it becomes minus 7. So 3 zeros are there. So 3.6 into 10 power minus 3. So approximately 3.6 millimeter. So you can go ahead with 3.5 millimeter. This is very important, students. In Young's double slit experiment, how many fringes are seen? Let us say N1, 62 fringes. For the wavelength 5893 angstrom, lambda 1. For the second wavelength 4358 angstrom, what is the number of fringes will be N2? So the number of fringes will be what? N2. So what's the formula here? N1 lambda 1 is equal to N2 lambda 2. So N1 lambda 1 is equal to what? N2 lambda 2. So if you want to find N2 value, it will be N1 lambda 1 divided by lambda 2. Remember, if they have given the number of fringes and the wavelength, when they are coinciding, its path difference has to be constant, right? If the two fringes are coinciding at the same point, the path difference must be a constant. So path difference means n lambda must be a constant. If n lambda is a constant, you can tell n1 lambda 1 is equal to n2 lambda 2. So what is n2 from this? n1 lambda 1 by lambda 2. So substitute n1, lambda 1 and lambda 2 and tell me the value of n2. What is n1? 62. What about lambda 1? I will write it as 4.3. Lambda 2 is 4.3. Lambda 1 is 5.8. So approximately you can calculate this. Approximately you can take this as 6 and this as 4. So how much you'll get? 5.8 you can take it as close to 6. 4 can be taken as 4. 4.3 can be taken as 4. So keep 62 as it is. If this becomes 6 by 4 means it will be 3.3 by 2. 3 by 2 means this is close to 31. 31 into 3 means it is close to 90. So option D will be the right answer. So approximately it must be close to 84. These two are not required. This is out of syllabus. This is very similar to your previous problem, 27th. It is similar to 27th. You can solve it later, students. Then angular width is not required. So this shift is also not required, students. Let me take some concept of all this is deleted in the diffractions now. Yeah. So let us take Molus law, which is very important for the exam. Molus law. Look at this. Unpolarized light. Unpolarized light of intensity I naught makes an angle of 60 degree with each other. The intensity of light emerging from the pair is. So when the unpolarized light is incident, what is the Molus law, students? It is I naught by 2 cos square theta, right? I naught by 2 cos square theta. Yeah, what is theta? You can take 60 degree. If you take theta equals to 60 degree, then cos 60 value will be 1 by 2. 1 by 2 squared will be what? 1 by 2 squared will be 1 by 4. So I naught by 2 into 1 by 4 becomes I naught by 8. So option B will be the right answer. Unpolarized light of I naught is false. What is the intensity of the emergent light? For one complete rotation, the intensity of the emergent light becomes 50% of that. So please remember that I naught by 2. Once if you incident the unpolarized light of intensity I naught to a polarized, the emergent light will be having 50% of that intensity, that is I naught by 2. I naught by 2. This is not required. This is not required. This you can solve it by using the same concept of Molus law, students. You can solve that later. You don't require this polarizing angle. Even this. You can also try this later. If you want, you can solve the 54th now itself. Unpolarized light is incident between the two cross polarized. Two cross polarized means the two polarized axes are perpendicular to each other. This is polarized A, this is polarized B. Now the second polarized is rotated by 30 degree towards A. If B is rotated towards A by 30 degree means, if I say this is 30 degree, initially A and B are perpendicular. What is the total angle? 90 degree. If that is rotated by 30 degree, what is this angle equal to? 90 minus 30, no? What is 90 minus 30? It will be 60 degree. So if the B is rotated by 30 degree, what will be the angle between A and B now? It will become 60 degree. So if theta is 60 degree, can you tell me what will be the percentage of the intensity? It becomes I will be I naught by 2 cos square theta. Theta is 60 degree. So it becomes I naught by 8. What is 1 by 8? What is 1 by 8? It is 0.125. So if you want to find that in percentage means you have to multiply into what? 100. So in terms of percentage, it is 12.5 percentage. 12.5 percentage. 12.5 percentage. So option D will be the right answer. Yes, students, here also you can solve this as an assignment. Later I will share this PDF. So these are the different types of problems you have to learn. But for the exam, definitely the problem will be based on constructive and interference concept. and it is based on the Malus law. Now, let us take the problems based on lenses, students. Let's just take the problems on let me check once we can solve it here. Yes, students, you can see the question here. I will take out the notes and I will write it there. What they have given an object which is placed at a distance of 75 centimeter from the screen. Two positions of convex lens of focal length 12 centimeter placed. So obtain the real images are. So what is the distance between the object and the real image? It is given as 75 centimeter, right? What is the position of the convex lens of the focal length of 12 centimeter placed? So obtain a real image or. See what they have given. There is a screen. There is an object. Between the object and the screen, the distance they have given as 75 centimeter. Now, if I place a convex lens of certain focal length f, so this will become the object distance. This will become the image distance. So what is your lens formula, students? It will be 1 by f equals to 1 by v minus 1 by u. So if I take 1 by f equals to u into v as the LCM, it will become u minus v. By the sign convention, you know that u should be taken as negative because it is coming opposite to the incident ray. So if I take that u is negative here in the sign convention, then it will become u plus v. So in the problem, you can take the object to screen distance they have given as 75. So u plus v is equal to 75 they have given. Therefore, 1 by f is equal to u plus v is 75 divided by the product of these two numbers, uv. Now, by taking the trial and error, focal length is given, isn't it, in the options? In the options, they have given 60 and 15, 50 and 25, And another one more data is given, right? Two positions of the convex lens of focal length 12 centimeter placed. Two positions of the convex lens of the focal length. Distance between the two focal length is given. That is 12 centimeter. Here also I can write. One more lens, what they are placing here, they have given this. The distance between these two convex lens, that is 12 centimeter. So for the first focal length and for the second focal length, the distance between them is 12 centimeter. So what will be the object distance and the image distance? So what is the first option? So two positions are given, right? So you have to find what is the real image or. Let me write the diagram here itself because there I can't write. You can substitute here only better, I think, students. Let me write for first convex lens only. This is the first convex lens. This is the object. Let us say the object is placed at U. Somewhere here the image is going to be formed. They are telling that the object and the screen is at 75 centimeter. So from the lens to this, I can take 75 minus U. This as image distance. Now, what is the focal length they have given of the lens? 12 centimeter. So what's the lens formula? 1 by F equals to 1 by V minus 1 by U. Focal length is 12. Image distance is 75 minus U. Object distance is U. But I think now you can find what is the object distance. What is the object distance? Can you solve this? Definitely will get a quadratic equation, right? 1 by 12 equals to, what is the LCM? 75 minus U into U. So it becomes U plus 75 minus U plus U, and U will be get cancel out. So 1 by 12 equals 75 divided by this is 75 U minus U squared. You can do the cross multiplication, students. 75 U minus U squared equals to, what is 12 into 75?
900, sir.
Yeah, I can find 900. Now it is U squared minus 75 U minus 900 equals to 0. Now this is a quadratic equation, students. By using the formula method, can you solve this? And finally, you will get with two values for u. You will get the two values for u. So based on that, you can choose the option. Use the formula method. Or if it is factorized, you can also go for the factorization, I think. $60 and 15 factors. $60 and 15 are the factors, no? Minus 75 can be taken as what? This is plus 900, right? Because we are shifting this term to RHS. So we can write 16u minus 15u plus 900. So if you take out u common, u minus 60. If you take out 15 common, you will get u minus 60. So u minus 60 into u minus 15 equals to 0. So this implies u equals to 60 or u equals to 15. So what are the object distance? 60 centimeter or 15 centimeter. First option, students. 60 centimeter and 15 centimeter. Okay. Look at the next question. It is also based on lens. Two plano concave lenses of glass of refractive index 1.5 have radii of curvature 20 centimeter and 30 centimeter. They are placed in contact with the curved surfaces towards each other, and the space between them is filled with liquid 4/3 refractive index. What is the focal length of the lens system is? Student, let me write the diagram for you first. Which type of lens it is? Concave lens. Plano concave lens. What is the radius of curvature? One is 20, the another one is 30. Remember that? Refractive index is 1.5. Let me write it here. Two lenses are they have given, right? It is what type of lens? Plano concave lens. This is plano concave. One more plano concave are there. That another plano concave is in contact, right? Concave surfaces are in contact. So this is one more concave surface. Blue color one is the first concave. Red color one is the second concave, plano concave. So which surfaces are in contact, students? Which surfaces are in contact? Concave surfaces are in contact. Okay. Now, the space between them is filled with what? Water. So this is the refractive index of glass, 1.5. What is the refractive index of this water they have given? 1.33, or you can take it as 4/3. Correct, no? And also they have given the radius of curvature of the first surface. How much? 20 centimeter. What is the radius of curvature of the second surface they have given? 30 centimeter. Let me check once. One is 20, the another one is 30 centimeter. 4/3, 1.5. They're asking to find what is the focal length of the system now. What is the focal length of the system now? Now, let me analyze this, students, because I have taken this problem where you can analyze all the three concepts. Now, let me take the first convex. This is a first lens, plano convex. The middle one is convex. The middle one is convex. The third one is once again the plano concave. So these are the combination of three lenses, right? Just analyze. This is first combination. The middle one is second one. This is the third one I'm writing. Yeah. Use the lens formula for the first lens. What is the formula for the lens maker's formula? 1 by f equals mu minus 1 or n minus 1 into 1 by r1 minus 1 by r2. 1 by f1 for the first case. What's the refractive index for this? It is 1.5 minus 1 into 1 by. What's the radius of curvature of the first one? Since it is a plane surface, it will be infinity. Radius of the curvature for the first case is 20. So 1 by f1 will be equal to 0.5 into minus 1 by 20, that is minus 1 by 40. So 1 by f1 equals to minus 1 by 40. Now go it for the second convex lens. Second one is convex lens, right? 1 by f2. What is the refractive index for that? It is 4 by 3 minus 1 into, since the radius of curvature for the first surface is 20, for the second one, sign convention, minus 30. This goes positive, second surface goes negative. So it becomes 1 by 20 plus 1 by 30. This will be 1 by 3 into LCM will be 60. So it will become 3 plus 2. So 3 plus 2 means 5. So this becomes 5 ones are 5 12s are 60. So 1 divided by 36. What's the focal length of the second lens 1 by f2? It is 1 by 36. Now similarly, you solve it for the third case for this. That is 1 by f3 is equal to n minus 1 into 1 by r1 minus 1 by r2. So 1 by f3. Once again, it becomes 1.5 because the third one is made up of with a glass. Into 1 by r1 is 1 by minus 30 because it goes the curvature opposite to the incident ray. And r2 value is infinity because it is a plane surface. So what is 1 by f3? That is 0.5 into 1 by minus 30. So 1 by f3 is equal to minus 1 by 60. 1 by 60. So this is 1 by f3. So you know 1 by f1, you know 1 by f2, you know 1 by f3. According to the concept, if all the three lenses are in contact, then the effective focal length 1 by f is 1 by f1 plus 1 by f2 plus 1 by f3. Now you simplify all these things. You know what is 1 by f1? So 1 by f is minus 1 by 40. 1 by f2 is 1 by 36. 1 by f3 is minus 1 by 60. Now take up the LCM, students, here and please simplify this. This I think end up with focal length. I think it is going to be between 60, 40. You can take LCM first. Then later you can solve it for 36. You'll end up with minus 72 centimeter. So the focal length of that becomes minus 72 centimeter. So only the thing, it is the combination of three lenses students. This type of problems will come in the CT exam. Apart from this, there is one more very frequently asked question, student. They will give one convex lens. They will immerse this in water. After immersing in water, they will give the focal length in air. They will ask us to find what is the focal length in water, and also they may ask to find what is the change in the focal length. Please remember this direct question. Focal length in water will always 4 times the focal length in air. If they are asking change in focal length, you can take focal length in air medium minus focal length in water medium. That is FA minus FW. If you want, let me see one more question. Yeah, look at this 29. If one surface of a double convex lens has been silvered, then its focal length F is. Take refractive index of material as mu and radius of curvature of the either surface as r. So there is a double convex lens, students. One face is going to be silvered, then its effective focal length they are asking. What is the effective focal length? They are using mu as the refractive index and r as the radius of curvature, and r as the radius of curvature. Yeah. Let me solve this. Let me write the diagram for you first. See here, they are talking that a double convex lens. They are talking about a double convex lens. One face is silvered. They are telling that the one face is silvered. Now, if I send the ray of light, it undergoes refraction. After refraction, it gets reflected. Why it gets reflected? Because it is silvered. Because of the silvered, it gets reflected. Once again, at this surface, it has to undergo refraction. So, what will be the effective focal length of this combination? How many types of refraction is, how many times the refraction is taking place in the lens? 2 times. So it is 2 divided by the focal length of the lens minus, because it is based like a concave mirror, minus what is the focal length of the concave mirror? Let it be 1 divided by FW or F concave, because it behaves like a concave mirror. Since it becomes like a concave mirror, the effective focal length should be, let it be minus F. 2 divided by focal length of the lens, we don't know, minus, you know that the radius of curvature is r equals to F by 2 or r equals to 2F. F will be r by 2. So according to the sign convention, this is also a minus sign because it is traveling opposite to the incident ray. So it becomes plus 2 by r. Plus what? 2 by r. From the lens maker's formula, you know that 1 by focal length of the lens is equal to mu minus 1 into 1 by r1 minus 1 by r2. So according to the sign convention, r2 will be negative So 1 by r plus 1 by r, it becomes 2 by r. So I'll keep this as 1 by f with negative sign. I'll keep this 2 as it is. Then it will become 1 by fl. 1 by fl becomes mu minus 1 into 2 divided by r plus this 2 by r as it is. So minus 1 by f equals to, so 4 into mu minus 1 plus 2 divided by r after taking out the LCM. If I multiply 4 inside, it will become 4 mu minus 4 plus 2. Whole thing divided by r. This is minus 1 by f. So this is nothing but 4 mu minus 2 divided by r. The pencil charge does come down, I think, students. Please, 1 second. Yeah. So it becomes 4 minus 4 mu by r. So what will be f then? It is r divided by 4 mu minus 1, I mean minus 2. So which is the right option you can see here? Option C, r divided by 4 mu minus 2. So this is the option, students. So these are some problems based on lenses and the combination of lens, students. Please refer this. If you have any doubt, let me clarify that in the next session, students. Is it fine?
Yes, sir.
Yeah.